to convert from vertex form to standard form. Sorry, backwards. Standard form to vertex form. So the warm-up today, we converted from vertex to standard. Now we're going backwards. And like I said, in order to do that, we actually have to complete the square. So I want to show you a visual of what completing the square actually looks like, because then when we do it mathematically, it'll be a little bit easier. All right. So let's look at this first problem here. Okay. So first off, if I'm looking at this vertex form right here, what's the vertex? So that's vertex form. What's the vertex? Owen. Not 3, -2. You're close. It's 3, +2. So remember, your vertex is always, if you have a x minus h squared plus k, your vertex is equal to hk, meaning you flip this sign, keep this sign. So this would be +3, 2. Now, here's my question. Based off of this graph, or based off of this function, do you think the graph is going to open up or down? It's going to open up. Why? What usually dictates that? The a value. What's the a value here? +1. All right, so it's going to open up. Mean my vertex is right here. So that'll be 3, 2. So if I want to determine the range, first off, we know range is what values? Is range x or y values? It's the y. So we're using the 2. Is that 2 going to be the lowest y value or the highest? So guys, look, if it's opening upwards, is this going to be my lowest y value or the highest? It's the lowest. So if I wrote this in interval notation, would it come first or second? So if it's the lowest, does it come first before the comma or after the comma? Remember, interval notation is from least to greatest, so does it come first or second? First. And we use a bracket. So what comes here? What goes here? Is it going up forever and ever? Come on, guys. We've done this 1,000 times. Is it going up forever and ever? Yes, so it's going to where? Infinity. You could have also said it was from y is greater than or equal to 2. Now, that was just review. So remember, with a quadratic, our standard form is y equals ax squared plus bx plus c. So, in order to put it into the vertex form, we have to use completing the square. So first off, without doing box method, all right, we're going to figure out what these perfect square trinomial equivalents are. So remember, if you have a plus or minus b squared, that's the same thing as a squared plus or minus 2ab plus b squared. So x plus 5 all squared is what? As a trinomial. So if I did box method, what would it be? So this is the same thing as x plus 5 times x plus 5. If x is a, 5 is b. What's a squared? X squared. Plus what? 10x, because 5 times x times 2, that's 10x, plus 25. Good. What's this one? So here's a, here's b. What's a squared? Guys, what's x times x? X squared. All right, negative 1 times x is negative 1. What's that times 2? Negative 2x, and then plus 1. So what would this last one be? X squared plus 8x plus what? Not 12, 16. All right. Now, again, if you don't remember the formula for that, just do box method. Okay, I don't care if you remember the formula. I just want to see if you could do it. But just do box method. If it's easier, you just got to remember that this is equal to that. If you give me x squared plus 25, I will kick you in the pants because that is definitely wrong. Now, given each trinomial of the form, what is true about the relationship between b and the value of c? So if we look right here, all right, bx and c. All right, so 25 and 10, for example. So if my c value is equal to 25, my b value is equal to 10. How do you think I can go from 10 to 25? What do they both have in common? What did 25 and 10 both have in common? 5. All right. And we know that 5 squared is 25, right? So we know that 5 squared is equal to 25. What's the connection to 10 and 5? 2 times 5. So if I wanted to go from B to C, I first need to get the 10 to be equal to 5. So how do I get 10 equal to 5? I divide it by 2. So that would make it 5. Then how do I make it 25? So how do I make 5 25? Not multiply by 5, but multiplying by 5 is the same thing as doing what to that 5? Squaring it. So that would be 5 squared, which is 25. So could we not say, since we use 25 and 10 as placeholders, that C is equal to B over 2 all squared? Is that not what we just did? We took our B value, which was 10, divided by 2, and then squared it, and that gave us our C value. So we took our B value, divided by 2, squared it, that gave us our C. Did that not happen? Yes or no? Yes. This is actually, so this right here is actually a very key piece to completing the square. All right. So let's look at these real quick. So each of the following trinomials is a perfect square. We're going to write it in factored form or in perfect square form. All right. So in other words, the easiest way to do this, since they're perfect squares, you take the square root of the first and last term, keep the sign of the second, and then write it in this form. Some binomial all squared. So, what's the square root of x? Or square root of x squared? X. So that goes here. We bring down the plus. What's the square root of 100? 10. So this is x plus 10 squared. Let's go here. Square root of the first, square root of the last, keep the sign in the middle. So this is the process for factoring a perfect square trinomial. You square root the first, square root the last, keep the sign in the middle. So what do you think this one would be? Not x plus 3, x minus 3. That's why I say keep the sign in the middle. Because remember, what's negative 3 squared? Positive 9. That's why it's a plus here. But if we do negative 3 times x, that's negative 3x. Negative 3 times x is negative 3x. Add them together, you get negative 6x. Okay, what about this last one? What would it be? X plus 1, what? Squared. So we square root that, keep the sign. Now, here's my question to you guys. What do these all look like to you in terms of vertex form? So in vertex form, what's the connection? What's the connection between what we just did and vertex form? Where do you think this comes into play? So all three of these, how can they look like vertex form? Say it one more time. Right, it's the x minus h squared. So all of these could be versions of x minus h squared. All right. So keep that in mind when we come back to this. All right. So turn the page. Now we're going to actually look at it from a perfect square trinomial method. So they gave us y equals x squared minus 4x minus 1. All right. So they first asked us if we just look at x squared minus 4x. All right. So x squared minus 4x. They want to know how we can make this a perfect square trinomial. So in other words, we need a c value. Now, we already found out previously how the b value connects to the c value. All right. So what do you think I'm going to have to put here? So let's look at this from the geometric perspective. All right. So here's what they gave us so far. They gave us x minus 4 or x plus 4 all squared. Or x plus 4x. Oh my God. X squared plus 4x. Jesus. All right. So they gave us x squared plus 4x. And I need to complete this squared. How many ones do I need to complete that square? 4. So if I drag 4 ones, that would complete the square. So in other words, this needs to be plus 4. Now, here's my question. We said that c is equal to b over 2 all squared. If I take this b value, this 4, and I divide it by 2 and I square it, will I still get 4? So if I do 4, I divide it by 2, and I square it, do I still get 4? Yes, I do. 4 divided by 2 is 2. Square it. That's 4. So that's exactly what we do here, even though it's a negative 4. So we do, all we got to do is just add b over 2 all squared. So in other words, I would do negative 4 divided by 2 squared. That's equal to negative 2 all squared. What's negative 2 squared? Not negative 4, 4. So that's what we need to add on to make a perfect square trinomial. So now we're going to rewrite this trinomial, the x squared minus 4x minus 1, to make the vertex form. So off to the side, I'm going to write out the steps. So here's the first step. Move the c value, or actually before you do that, if my pen would work. So step 1, sorry. Set trinomial equal to 0. Then move the c value to other side of equal sign. And remember, for that, you got to use inverse operations. Then add b over 2 squared to both sides. Factor the perfect square trinomial. And finally, move the number on the right of the equal over to the left. Again, inverse operations. Meaning you're going to add if it was originally negative, subtract if it was originally positive. So let's actually do those steps in order. So step 1, I want to set x squared minus 4x minus 1 equal to 0. Now I do that because when I move things to the other side, it just makes my life easier. So step 2 is to move my c value to the other side. What's my c value in this polynomial? Negative 1. How do I move it to the other side? So I'm moving this negative 1 to the other side. So it's negative. So to get to the other side, I have to do what? If we're subtracting it originally, that means to move it to the other side, I got to add it. So I'm going to do x squared minus 4x. I'm going to leave a big space because I need to fill that space. It's going to equal to 1. Step 3, I'm going to add b over 2 squared to both sides. What's my b value? So what was my original b value up here? Negative 4. So I'm going to add negative 4 over 2 squared to both sides. Because remember, whatever we do to one side, we got to do the other. Now, off to the side here, Negative 4 over 2 squared. What's negative 4 divided by 2? Guys, I know it's time change, but give me something. Come on. Negative 2. What if you square it? 4. So this would be x squared minus 4x plus 4 is equal to 1 plus 4. And then what's 1 plus 4? 5. So this is x squared minus 4x plus 4 is equal to 5. My fourth step was to factor the perfect square trinomial, which is right here. So remember my trick for factoring a perfect square trinomial. You square the first, or square root the first, square root the last, keep the sign in the middle, and then make sure it's in this form. Yes, yes. So what's the square root of x squared? X, bring down the minus, square root of 4, 2. And we bring down the equal to 5. My last step is to move this 5 over to the other side. So how do I do that? Subtract it. So this will be x minus 2 squared minus 5. So we do not combine the 5 with the 2 because of that parentheses. All right. The parentheses and the square, that square means we can't touch what's inside those parentheses anymore. So the 5 just goes on the outside, still equal to 0. Now, what does this look like to you guys? What does that little statement right there look like to you guys? It looks like vertex form. So if I rewrite this without the 0, y equals x minus 2 squared minus 5. And that's my vertex form. Now let's see if that corresponds with my graph. So based off my vertex form, what should my vertex be? Positive 2, negative 5. Is that not the vertex here? Is positive 2, negative 5 the vertex here? Yep. Positive 2, negative 5. So this is the correct form. So completing the square is not hard. It's just a lot of steps. So that's why I wrote out the steps and then did them like in order next to it so you can see where it lines up. Any questions? All right. Now this square right here is just the steps again. All right. You can either follow mine or follow these. They're pretty much the exact same. I think mine is just a little bit more, I don't want to say dumbed down, but it's just kind of more, a little more specific, I should say. All right. So let's try some more. So let's look at letter A. First off, let's just get some stuff from the standard form. So based off of the standard form, would this graph open up or down? It'll open up. So would it have a max or min if it opens up? Has a min. And what's the y-intercept? It's what? 0, negative 2. Good. Now, let's convert to standard form so we can figure out what the vertex is. All right. So first things first, I'm going to set that entire trinomial equal to 0. What's my next step? So what's my next step? Add 2 to both sides. So I got to move that c value to the other side. So I have x squared plus 6x leave a space so I know I got to fill that, is equal to 2. Then what do I do? What do I do next? Add b over 2 squared to both sides. What would b over 2 squared be? So what's the b value? 6. So it would add 6 over 2 squared to both sides. Now, 6 over 2 all squared. What's 6 divided by 2? 3. What's 3 squared? 9. So we have x squared plus 6x plus 9 is equal to 2 plus 9. So what's 2 plus 9? 11. So this would be x squared plus 6x plus 9 is equal to 11. What's my next step? Not yet. I gotta do something first. What do you guys think I do? So we gotta make it look like vertex form. So I gotta get my x minus h squared. How do I get that? Nope. I gotta do what? So in other words, I gotta factor the perfect square trinomial by doing the square root, keep the sign method. So I gotta take the square root of the first, square root of the last, keep the sign. So what would it look like when I factor it? What's the square root of x squared? Square root of x squared. X. I bring down the plus. Square root of 9. And then what do I have to put right here? Square. Now I subtract over the 11. And remember, do not subtract it to that 3. Leave the 3 alone. So this is x plus 3 squared minus 11 is equal to 0. So if I pretty it up a little bit, I get y is equal to x plus 3 squared minus 11. So you cannot subtract that 11 back over until you factor that trinomial. And remember, all you got to do is it's going to be a perfect square. So you should get the same binomial squared. So you just take the square root of the first, square root of the last, keep the sign in the middle. So based off of that, what's my vertex? -3, -11. Good. So what I want you guys to do next, I want you to try letter C. So first off, before you start letter C, does it open up or down? It opens up. Is that going to be a max or a min? Min. What's the y-intercept? 0.27. All right. Now, complete the square. So I'm going to leave this up for y'all's reference. Yes. Yeah. So I'll give you a minute. Complete that square for letter C. So the vertex form. And all my little sleepyheads, sit up. No time change. No big butts. We all gotta be here. just follow step by step what I did. I left it up for your reference. It's not too bad. One more minute. More. So you're subtracting. All right, take a minute, compare answers with your group. All right, my darlings, let's come back together. All right, let's go over this. So let us go with Wendy. What's my first step to completing the square? Say it again. Right, so if I first set this equal to 0, you would subtract 27 to both sides. So I get x squared minus 10x, leave a space, is equal to negative 27. All right, Caden with a C, what do I do next? Right, so I'm going to add negative 10 over 2 squared, so b over 2 squared to both sides. And Caden, what is b over 2 squared in this case? So what's negative 10 divided by 2? Negative 5. So what's negative 5 squared? 25. So in other words, I'm going to add 25 to both sides. So if I add 25 to negative 27, that's negative 2. So x squared minus 10x plus 25 is equal to negative 2. What's my next step? What's my next step, Jared? Right, we need to factor it, so we take the square root of the first, square root of the last, keep the sign of the middle. So Jared, what would that be? So x minus, because we bring that term down, square root of 25. Five. Then we make sure we square that. It's equal to negative 2. What's my last step? Let's go Addie. Say one more time. I just can't hear you over the fan. One more time. I just couldn't hear you over the fan. So then we add 2 to both sides. So this would be y is equal to x minus 5 squared plus 2. So that right there is my vertex form. So what's my vertex? Anyone, what's my vertex? 5, not negative 2, positive 2. Any questions on completing the square? All right. Your homework for tonight is page 34 and 35. So page 34 and 35. So homework for tonight, page 34, 35. If you did not do your homework from over the weekend, you're in luck. You get an extra day. I'll check it Wednesday because I won't be in here tomorrow. Yes. Yeah. So remember, guys, substitute tomorrow. Make sure